All right, start chapter 10. We're going to look at solids. Today's lesson is going to be I will learn to classify three-dimensional figures, and I will learn to use nets and cross sections to analyze these three-dimensional figures. So first we're going to kind of define some things. A three-dimensional figure is also called a solid, and it can be made of flat or curved surfaces. Each flat surface is called a face, as you see right here in this drawing. An edge is a segment that is the intersection of two faces, which would be these lines coming down or across horizontally. And a vertex is a point that is the intersection of three or more faces. So each of these corners is probably, we would call them, those would be actually vertices. Right? And then we need to actually define some of these different types of three-dimensional figures. And we'll go ahead and start with the first one, which is a prism. Now, a prism is formed by two parallel congruent polygonal faces called bases, connected by faces that are parallelograms. All right, so those are the bases are going to be the two that are parallel to each other, and everything else is going to be some form of parallelogram or rectangle. A cylinder is a shape made up of two circles that are parallel, and then the surface that connects them is curved. Then we have a pyramid. Pyramid is a polygonal base and triangle faces that meet at a common vertex. And the last one we're going to talk about is a cone, and that's formed by a circular base and a curved surface that connects the base to a vertex. All right, next one is a cube. It's a prism with six square faces. Other prisms and pyramids are named for the shape of their bases. So if we look at these here, this is a triangular prism because the base is a triangle. And rectangular prism because the base is a rectangle. Pentagonal prism because the base is a pentagon, etc. The same kind of base, but these are pyramids. So you can kind of compare these two and see the differences. Triangular or prisms, I have two parallel bases. On a pyramid, I just have one base, and all the faces meet at a vertex. So let's look at a shape. We want to classify the figure and name the vertices, edges, and bases. So this would be called a cube. Nothing too complicated there. Vertices are just going to be all the different points and corners. So we'll just say A, B, C, all the way to H, looks like. A, B, C, D, E, F. Gotta remember my alphabet. Okay. Now the edges are going to be all of these, the segments. So that's going to be AB, BC, CD, DA. I'm trying to go in order here. Then we have EF, FG, GH, and EH. Right, and I'm going to do the ones that come down. So that's going to be AE. Then we have BF, CG, and then we'd have DH. Okay, and the bases are going to be ABCD would be one base, and then we would have EFGH would be my second base. Now notice for my vertices, I separated all the letters with commas because that tells me that I'm looking at points. Since I'm looking at edges, and these edges happen to be segments, I had to put the little bar on top. And then for my bases, I didn't put any commas except for the one that separated the two bases. That's going to be important when you're writing this stuff down. Right. I'm going to leave this one up for you, other than I'm going to give you the name. This one's actually a pentagonal pyramid. Right. And remember, the pentagon it gets the first part of it because of the base. The base is a pentagon. Okay. Now put this one on the side because your solids on this stuff is going to be rotated. It doesn't always mean that your bases are going to be actually on the bottom. These shapes can be twisted and rotated any direction, but it's the base that's unique on this pyramid that gives it the actual name. Alright, next we're going to talk about a net. And a net is a diagram or a drawing of the surfaces of a 3D figure that can be folded to form the three-dimensional figure. So basically it's a, if we want to kind of do this a little simpler, it's two-dimensional. The way I like to think about it is it's a two-dimensional drawing of a 3D figure. Okay, so we kind of fold it out and flatten it out, kind of like this. Right? If I were to cut this out and fold it up, what shape would it make? And for this one, since all of these surfaces are the same, this is going to actually form a cube. Right. For the next one, all of these are triangles, and if I were to take these and kind of fold them up, this would actually form a triangular pyramid. Okay, and we'll practice some more of this in class, and so you can practice and see what, if you were to cut these out and actually fold them up, what they would make. Next thing is we're going to look at is the cross section. Now that's the intersection of a 3D figure with a plane. So that's going to look like these things down here. Okay. So here's my cone, and I'm cutting it or slicing it with a plane. So on this one, if I kind of cross it right at the top, it's going to form a point. However, on this one, I'm kind of slicing this pentagonal pyramid somewhere inside the figure. So what ends up forming is this actual shape right here, which is kind of a smaller version of the pentagon, the base. Now on this one, if I cut it going vertically and I look at this, that's going to form a triangle. If I were to cut this shape, slice it in half, and I looked at what I cut, it would form a triangle. Alright, next example is a piece of cheese is a prism with equilateral triangular bases. How can you slice this cheese to make each different shape? So the first one we're going to look at is to make an equilateral triangle, and then we want to slice this block of cheese or piece of cheese to form a rectangle. So kind of a little bit of, I guess, an art lesson here. We're going to draw this out first. And you draw a triangle, and then you kind of draw another triangle that's about the same size right above it. Right, and then you connect your edges here. Right. And there's my equilateral triangle, or my triangular prism. Now, I want to slice this thing so that it forms an equilateral triangle. Well, these bases right here are equilateral triangles. So if I want to cut this, I'm going to cut it using, or going, I guess, parallel with the bases. All right, I'm going to do that. I'm going to go ahead and take, I guess, just kind of pick some points right here where I would slice it, and just kind of connect those 3 points. All right, so if I took something and I cut it this way, it's going to create that equilateral triangle. All right, but now I want to get it into form a rectangle. So I'm going to redraw this picture. So again, I just want to draw 2 triangles, one above the other. Try to make them about the same size or close to it. And then you connect your vertices. All right, now this is going to be a little different because I want to cut it. I can't cut it horizontally because that's going to make a triangle. However, if I cut it vertically, if I slice it down this way, I have these edges right here. And if I cut them this way, that's how I would get a rectangle. Okay. So to answer, I guess, question 6A, I would slice the cheese horizontally. And to make it a rectangle, I would slice vertically. All right, and that, of course, is not the only way you can slice these. You can kind of come in and slice it from here, going back down this way. You can just cut off a piece off the edge. But as far as answering these two questions, that's how you would cut them to form these two shapes.